Hello and welcome everyone. In this video, I'll be walking you through a hands-on example that I've prepared for LLM orchestration using Prefect. So it's a full-fledged demonstration of how you can use Prefect to orchestrate your workflows that involve AI model interactions, especially with Llama 3.2 in this case. And the repo link is in the description. You can feel free to clone it and follow along. But before we jump into the demonstration, let's break down what we are going to cover today. We have data pre-processing. So before we interact with the large language model, we want to make sure that the input data is clean and it's ready. Just like any real world machine learning task, proper pre-processing is critical to ensure we get accurate results. And then, of course, there will be an LLM interaction. So once the data is clean, we'll pass it along to our LLM model using Prefect, which orchestrates the entire process and ensures everything runs smoothly. Then we have persistence and error handling. So in any real world application, persistence is the key. We look at how Prefect helps us to persist data and handle retries in case of failure. So our system stays robust and reliable. We'll invoke certain hooks for this purpose, and we'll talk about that in detail very soon. And then at the heart of everything, a Prefect flow is involved, which will get deployed, and we will use some APIs that Prefect provides to invoke those flows too. So this setup not only manages the machine learning pipeline, but also ensures a proper way of invoking a flow, logging, and event handling. So all that being said, let's dive directly into what we are going to see today. So on the screen right now, you can see that I have a flow mentioned. So there is a task for cleanup data in the flow. There's a task for processing data in the flow. And then there are certain hooks. So these hooks are some events. For example, if the flow is successful, then on completion hook will be invoked. And if the flow fails, then on failure hook will be invoked, right? So in either case, we want to store the data. We want to make sure that everything that is processed or was supposed to be processed is done accurately. So how we are accomplishing all this? So of course, we're going to see today a Prefect server where we will have our flow deployed. Now, the key point over here is we do not deploy the code over here. The worker isn't here, but the actual configuration of the deployment, right? The configuration of the flow, which is the deployment, gets served and put on this particular Prefect server. Then there are certain workers that can associate themselves to that flow, and they will be in a way listening and waiting for any tasks to be done. The workers are the one that will interact with our large language model because they'll receive the task, they'll have access to code, and then they will execute that particular task and flow for us. And then on completion of the result, we are going to store the result in a PGSQL database, right? So in a Postgres database, we'll store the results over here. How are we going to invoke such a flow? So one of the options is you can always schedule it using an expression, but you can also invoke such a flow using either a Python application, or you can invoke it using an API call, a REST-based API call, which is what we'll be taking a look at today. So we'll send a request from an application separately, and that request will be received by the Prefect server. Prefect server will then, in a way, schedule the flow to be run, and a worker which is listening for this particular flow over here will pick up the work, process the work, right? So it has certain tasks that it will follow, like cleanup data, processing task, and then it will do whatever processing task is, which in our case involves interaction with large language model, and then it will store the result in the database. Let's see how all that is happening in the real life, and let's take a look at the code now. So there we go. This is our code base that we have. So we've already seen where our code base is. So all you have to go is to github.com teachings on this repo. The Prefect server, the Prefect LLM orchestration, this is where all the code over here resides. The one that we'll be taking a look at today is the H event persistence over here. So this is the folder that we'll take a look at today. I've already git cloned it in my repo, in my local over here, and H event persistence is what we're going to take a look at. So the flow starts with llm flow.py. So I'm just going to open this and kind of maximize, make the font size bigger so it's easier for you to read. And while I do some operations over here, I want to make sure that my Prefect server has started and my Prefect worker has started, right? So in our example over here, I want to get the Prefect server up and the Prefect worker up. And I will also show you that the Ollama server is running as well for us, right? So these three servers, workers, and stuff that are going to be set up, I'll show that. And then we will go ahead and deploy a configuration, a deployment of a flow configuration on the Prefect server. So let's do that. So step number one, I'm going to get the Prefect server up and running right now. So there are some simple commands to do that. You go into the you have to activate a conda environment, and I've talked about all this in the previous video, so I don't want to go into detail over here, but you have to create and activate a conda environment, which I've already done, and you have to then go ahead and set your Prefect config for your API. So I'm going to set the config for API as the 0000, so this local host over here 4200/API, that is the Prefect API URL, and I'm gonna start the Prefect server over here now like this. So just copy and paste and you start it like this. So once your Prefect server is up, right? So you will see nice written font of Prefect and your server is up now. So once the server is up, you can go ahead and start your worker pool. But before we start the worker pool, right? Let's keep that thought for a second over here on the side, and we'll start the worker pool in a little bit. But first, let's go ahead and deploy our configuration of the flow. But let's talk about what is this configuration, right? What is this flow? Let's go into some details of this Python script, and then we'll go ahead and we'll deploy it. So in our current flow, we have two tasks. And where are those two tasks? Let's take a look. So there is a first task of cleanup data and second task of processing data, right? So we want to execute these tasks in this order. And then if these two tasks have succeeded, we want to invoke a certain hook to store the data or not to store the data, right? So we'll take a look at that now. So where are those two tasks? So in our code, we see these two tasks over here. So there is a pre-process question, and what this task is doing over here is it is pre-processing any bad data out of it, right? So we have, let's say, an English question being asked, like, who is Mahatma Gandhi, right? Or where was Barack Obama born, right? Any question that we are asking our large language model. And let's say we put some special characters in between in there, and we do not want that. So in this particular pre-processing example, you will see that I have cleaned out any bad data from there. So what I'm saying is keep only English characters upper and lowercase in there, 0 to 9 in there, and anything else just remove it. We don't want it. And at the end of the question, we always want a question mark. So just end with a question mark, right? So in our use case, the first step of the flow is a question. We know that. So we are cleaning up the data so that it looks like a question for us, right? So we are going to take in junk data in this pre-process question method, and we will return a cleaned data out of it. So that is the step number one, the first task that we have. And we can see that we have two retries over here, because most likely this is not gonna fail, right? I mean, it's just an internal process. I don't see any reason for it to fail. I've just set retries over here as a demonstration, but anything can happen in real world scenario, so be prepared for it and put some retries with some delays over there so that a process can be retried if it has failed. Now, the second step of the flow is ask LLM a question, right? So what is this? So in this step, after we have cleaned up the data, right? Cleaned up the step one where the question has been taken care of, any junk from the question has been removed. It is now passed on to be sent to a large language model. And the way we are interacting with large language model is by using OpenAI Python library over here, and it accepts the payload in a particular format, which is right here. So the payload that this Python library expects is in this format, where it wants to know what's the model you are interacting with, and it wants to know this particular role system and role user and the content of system prompt and the user prompt. So the system prompt, it's just a simple system prompt. You are a helpful assistant. And the user prompt here is the pre-processed question that we are getting as a cleaned question from the step number one. So step number one is going to clean up the question, and step number two will take that cleaned up question as an input, and it will pass it along to the large language model for asking that question to the large language model, right? So system prompt and user prompt is being put over here as the second task. And once you get the response back from this particular large language model over here, once you get the response back, then you just return that response back over here, right? So now let's go take a look what the final flow is. So there were two tasks in the flow, pre-processing task and actually doing the data operation task, right? So both the tasks are mentioned over here, pre-processing and data operation. Now, once you have the tasks created from within the flow, you can invoke these tasks, which is what we are doing over here. So from within the flow, we are invoking these tasks. So we take a question as an input, right? This question can have some junk data in it. So we pre-process that, and we get the pre-processed question, and then we pass it along to our second task of ask LLM question, and we get an answer back, and then we return this answer as a flow. So what will this be? This will be the return from the flow, which is the final result from the flow, right? So this is recorded within flow as a result. Now, there can be two different events originating over here. Event one could be on completion, if everything completed perfectly, and on failure, if things didn't go right. So whenever these two events are raised, then these particular methods will be called, right? So there's a method called on-flow completion and on-flow failure. These two methods will be invoked, but where are they? So if you see on the top of the file again, so I have created a hooks.py file over here. So these are the on completion and on failure hooks that I have overridden in a way, right? Well, you just have to associate them with on completion and on failure, but you can think of them like an overridden flow. So you just have to specify what the Prefect server needs to execute if the flow has completed successfully. And this is the on completion flow. And then what it needs to do when it has failed, this is the on failure flow. So let's take a look at hooks.py over here. This could have been any name. I just named it hooks.py and imported it and linked it at the bottom. So let's take a look at hooks.py. So we are saying that on completion of this particular flow, we want to invoke store result method, and on failure we again want to invoke store result method. However, when the flow is completed, we are invoking the store result method using these are the four parameters over here, right? So we have a flow run ID, flow name, result, and success as the type over here, right? So there are 4 attributes that we are storing: flow run ID, flow name, result, actual result, and success. And if the flow is failed, then we are storing the flow run ID and flow name. So all those 2 things are exactly same. However, the state, because if the flow has failed, the result isn't available, right? So what we are trying to store is the state of the result. So we store the state of the result, and then we store an attribute that it is failed. But what is this store result, right? This is another method that has been created over here. It's an async function that will go in and store this particular result in a table in Postgres database. And the way we are storing the result in the Postgres database is by actually, I haven't talked about that yet, but in a Docker Compose file, we are spinning up a database, the Postgres database in a Docker container, and we are creating a table within that database. So there is another Python file over here. Let me quick show you that and come back to hooks. So there is a create table Python file, and the purpose of this Python file is to go in, use certain properties over here, and these are very insecure database password and stuff, so definitely not a production ready setup over here, but it's good enough to show the demo. So there are some database connection parameters and database creation parameters that are defined. And based on this, if the database doesn't exist, then using the scikop-g2, we connect to the database, we create the database over here, we create the table over here, and then we also, in the models.py, if you take a look over here, using the models.py, we create a table called flow results, and in this flow results we create certain columns over here, right? So these are the following columns that you were taking a look at when you were storing the results: flow run ID, flow name, status, and result. These are the 4 details that you were taking a look at, and then there is some metadata on top of it, which is all right. So if we come back to hooks.py now, you will see when we were storing the result, these are the 4 main attributes that we were using when we were storing the result. All right, so when the flow has completed, right? So there is a LLM flow. When the flow has completed, on completion, this particular method will be invoked. And if we take a look at this method, it says that on completion, you have to store the flow run ID, name, and result over here. And you can see the result I'm obtaining by state.result in this case. So whenever the flow on completion is achieved, you have the state available that you can extract the results from, right? So which is what we are doing over here. So flow run state. So you have the state available over here. You can extract the results from there. And then using the result, you can store it using the store results method from this. So this is a very simplified view of some real world processing that is normally done. Right? So now you have the capability of executing a flow, and on completion, you can take one action, and on failure, you can take another action. So before we go ahead and deploy the flow, let's spin up the database. Let's take a look at the Docker Compose file. So what is this Docker Compose file doing? All it is doing is it is just getting a Postgres 3 database, and it is, again, if you see the user password and DB is similar to what you would see in the port over here, right? So it's similar to what you would see in the create table, right? So there was name, user, password, port, right? Host, all those things, they are mentioned over here. So you are going to be spinning up a database with these environment variables, and then when you connect to this, you'll be able to then create and do CRUD operations on it using these credentials. Okay, so there's one more thing you'll see in this Docker Compose file. There is adminer, and adminer is like a nice web-based interface that helps you. It's very simple web-based interface that helps you in visualizing the Postgres database. Okay, so how do we get this particular thing up? So the easiest way to do that is let's do a docker compose up minus t over here. So let's do that. Docker compose up minus t, and are we in the right h event persistence? So let's see what am I doing wrong. Compose is spelled wrong over here, of course. I pressed a tab. Okay, docker compose up minus d, and it is spinning up these two containers. And let's just do a docker ps, and we can see that those two containers, adminer and Postgres, are up. Okay, perfect. So now that these two are up, let's visualize this particular database first and see, because I was playing with it earlier, most likely it will have some things in there. So let me see. Localhost colon, and I think it was 8080. Let me take a look at the docker compose file. Yep, 8080. So adminer is running on 8080 and Postgres is running on 5432. So localhost 8080, and this is our adminer interface. At least it should show up over here, the adminer interface. So just a second. Perfect. So our adminer is up, and yeah, because I was playing with it earlier, you can see that some of these credentials are already in here, but you have to choose Postgres over here, and the DB name is Postgres because that's what we have specified. So you can see that we have Postgres as the DB name, the DB server, Postgres over here as where is it? Postgres as the DB server. So we are choosing that as the DB server over here. The database name is Prefect DB. So let's choose Prefect DB as a database name. Username and password. Username and password has been entered, right? So let's do a login and log in into this. So now you can see that there is just one table over here, right? There's just one table created, and the reason why it is because I was playing with this. What I'll do is I'm going to go ahead, click and drop this table. So you will have the same empty database like I have right now, and I'll have the same empty database that you have. Right, so there's nothing in this particular Prefect database. It is empty. So now let's go ahead and run this particular create table.py method, this Python script over here, and what it will do is it will connect to our Prefect database and create this particular flow result table for us, right? So let's do that. So we will Python create tables.py, and let's run this and have it create the table and the database over here. Perfect, right? So Prefect DB, it says it already exists, so it doesn't need to create it, but it did create the table successfully. So let's visualize that. I'm gonna go and refresh this page over here, and Postgres, Prefect DB, and flow results, right? So we got the flow results table created. All right, perfect. So we have everything that we want. And next, what we have to do is take a look at this particular LLM flow. So we already talked about what the flow is, right? So we have a pre-processing step, we have a ask LLM question step, and we have a flow that executes those two steps and then takes some operations on completion and on failure. Before we go ahead and deploy it, let's run this flow and let's visualize whether it is working or not. So in my use case, I have my server, my AI server, installed at AI:11435/v1. However, in your case, it most likely would be a local machine. So you can do localhost:11434 over here. I just happen to have it on a different server where my OpenAI's base URL is, right? So my Ollama server is on a different server is the point I'm trying to make over here. So let me go ahead, open the terminal, or I can actually run this from here too. So let's do a Python llm flow.py, and you will see that the question that I'm asking to the large language model is who and bunch of random characters is Mahatma Gandhi, right? So this is a question that is not well formed, right? So this definitely needs a data pre-processing. And in our data pre-processing step, we just want to get rid of all this junk that is in between, and we want to add a question mark at the end, right? So let's see how we do this. So Python, and this file is llmflow.py, and let's see what happens over here. So it goes in, and oops, it goes in, and it is asking LLM the question, and the question it's asked is, see, it got rid of some of the bad data from there, put a question mark at the end, and it is attempting to run this particular task right now. So it'll take a couple seconds to finish this, and while it is running, we can visualize this on the Prefect server also. So what we can do is we can go to localhost :4200, which is the Prefect server URL, and you can visualize this particular run. So in this run, you will see that there was a LLM question flow, and let's click on this. And you will see that there was a pre-processing step where we asked a question who, and a junk question is here, is Mahatma Gandhi. The cleaned up question was who is Mahatma Gandhi, and then this particular task was done, the pre-processing task was done, and the information was sent to the next task over here, which is ask LLM question task. And ask LLM question then responded back with all this information over here, and then the state was completed. Right now the on flow completion was invoked because it was finished successfully, the state completed successfully. So on flow completion hook was invoked. Let me make it bigger so it will be easier for you guys to read. So on flow completion was invoked, and then store flow result with the status of success, right? So it stored that, and the hook on flow completion finished successfully, and that resulted in finishing of the full execution of the flow. Let's visualize the database also, and let's take a look if the table has any data now. So let me reload this, and let's see if I, oops, no, not this. So flow results, select flow results. What am I doing wrong over here? Reload. So Prefect DB, this is where we have our information, and of course I have to choose the schema also over here. So let me choose the public schema, and in this public schema, in this database, I have this flow results. So let me click on this, and select data, and this is our entry that just got in. So the most important thing we have is flow run ID over here. This can be associated with the flow run ID that we are going to be looking at in the Prefect server too. So in the Prefect server's flow run ID, we can visualize that. So let's see where we can see the flow run ID over here. So in our case, the flow run ID should be somewhere over here. Copy ID, and well, it's right here too, but it's also available if you come over here and copy ID. There's also another way to visualize it. I'm trying to find where did it go. Details and flow run ID right here. So you can see the flow run ID is 9FE and ends in CF94, and we can see in the database too 9FE and ends in CF94. So this is the Flora ID. And the actual result that we have is right here. So this is what it responded back with, the large language model, and this is what we have stored the result in. So if we go back and we take a look at our actual architecture diagram we were looking at. So we haven't deployed anything yet on the Prefect server, right? We just ran that particular flow to make sure that it is working fine. And we have been able to execute the flow and we have been able to reach out to the large language model. We've been able to store it in the Postgres database. So now the next step is, let's go ahead with the deployment of this flow, right? So let's go ahead and do that. So next step would be we'll go ahead and choose this option of Prefect deploy. So I'm going to come back over here and I'll choose Prefect deploy. So one thing I'll want you guys to be careful of is, let's say if I do a Prefect deploy and I create a YAML file that is stored over here, that YAML file configuration would be for me. So I would encourage you to delete any YAML file that already pre-exists in this particular folder. The YAML file, which is the Prefect YAML file, not the Docker Compose and any other thing. But you'll have to make sure there is no Prefect configuration YAML file in there. And if it is, the Prefect deploy reuses that. So you just want to create a new one for you when you are deploying for your own server. So Prefect deploy, enter, and it is asking you to choose which particular flow you want to deploy. So we want to deploy this flow. There is only one flow in this folder, LLM question flow. And we want to choose that. And the name of this flow, we want to have LLM-flow over here. And then it's asking, do you want to configure any schedules? Nope, we don't. We want to manually trigger this all the time. And then it's asking that there is no worker pool. Do you want to create a worker pool? Yes, we do want to create a worker pool. And this worker pool we want to have as a process worker pool to keep things easy and simple right now. So we're going to create a process worker pool, and the name of the pool will be default for us, just a simple default worker pool. And it's asking that, do you want to fetch your code from a remote location? No, we don't. All the code is right here. We don't want to fetch from a remote location. So I'm choosing no. And then it says that, do you want to save your configuration of this deployment for faster future deployments? Let me choose yes, right? Let me choose yes. However, you do not have to save this for future deployments, right? So you only want to save it if you want to save this flow. You want to deploy it to a different Prefect server, or you can always regenerate all these options next time again if you want. But I like saving it because I can have a snapshot and copy of it in my code itself, and I can visualize this, what I'd done, right? So I'm going to choose yes over here, and you will see that it will create a Prefect YAML file on the left-hand side for this particular flow. So I chose yes, and it created a prefect.yaml file over here. So just make sure that when you are, if I leave this in the Git repo, make sure that you delete it when you are choosing your own Prefect deploy. Why do I say that? Let's open this Prefect YAML file, and you will see that the directory that I have mentioned over here is this directory. You may not have the same folder structure for your working directory. So you'll want to choose a different folder structure if you want to reuse this Prefect YAML file. You want to make sure that you have your own directory structure over here, or in general, just choose a Prefect deploy from scratch, and that will work. Okay, so what we have done now, if we go back to our Prefect server and if we go to our deployments, you will see that there is this new deployment LLM flow available. So this deployment is available. However, you cannot execute this deployment. You cannot run this deployment. If you attempt to run it, it will fail. So if you put any question over here, attempt to run it, well, it won't really fail, but it will not really run your deployment because you do not have any worker over here yet. But then you'll think, no, we did create a worker. Yes, we created a worker, which is over here in the worker pool. We created a default worker, but we never started the worker. So the second thing that we have to do is we have to start our worker pool, right? So we're going to choose this option. It right over here says to start your worker pool, you have to run prefect worker start -- pool default, right? So default pool we have to start. Now in Prefect 3, this concept of agent has been moved to the more machine learning areas, and the concept of worker has taken over as the old concept of agent. So if you're coming from Prefect 2, you will realize that worker is a new term over here that we are using, but it is the same thing as the old agent. Okay, so we start the worker pool, the default worker pool, and you can see that it already picked up the task and it is starting to process the task too. So this already happened, and you can see if I go back to the deployments, you will see the deployment is ready and it has already run one flow where I had asked the question hi. So I had already put the question, submitted it, and whenever the worker connected, it picked up that question and it processed it. All right, because the worker processed it successfully, let's see if the onFlow completion was invoked. Yep, it was invoked. And you have so in our database, you must have your results stored. Let's take a look at that. So earlier we had only one entry over here. If I refresh this, there is a second entry now in the database. So you have a full log of everything. In a way, you have your whole chat history over here with you. You can enable an agent's long-term memory if you want to by storing the results coming back from your large language model directly in your Postgres database. Okay, so what have we done up until now? Let's go back to our architecture diagram and take a look. So we have now been able to deploy the flow on the Prefect server. We have been able to connect a worker to the Prefect server. And this is just a process worker, but yet it's a demonstration of a worker connected to the Prefect server. And you can manually trigger a flow. And once you manually trigger a flow, it gets queued on the Prefect server. And if a worker is connected, that picks up this flow and it processes it, right? So it processes it, and whatever are the steps of on completion hook, it will do that, and it will store the result in the Postgres database based on the on completion hook's result. But what we haven't done up until now is to invoke the flow from API. So let's do that next. We'll do an API call to the Prefect server, and we will remotely invoke the flow by the API call. Let's do that. So what I'm going to do is go back to the Visual Studio Code, and you will see this is the last file over here, triggerflow.py. So in triggerflow.py, there are certain things that you have to specify. So step number 1 is you need to know what is your flow name and what is your deployment name, right? These two things you need to know, because a combination of flow name and deployment name will result in finding the run ID. So your flow run ID would be dependent on your flow name and deployment name, right? So what I mean by that, so whenever you are working with Prefect, you are working with these flow run IDs. So if you go to the flows, or actually in your deployment, you have your LLM flow. So there is a flow ID over here. This is the flow ID that we are looking for. We are going to be executing the flow based on this particular flow ID. So you can get this flow ID by passing a flow name and deployment name. So the unique combination of flow name and deployment name will help you find the flow run ID, and then you can execute the flow by calling an appropriate API endpoint of Prefect server. So the API endpoint to get the flow run ID is by passing. Let me show you this over here. So on the very top, you will see there is a base URL. So the base URL is your Prefect server's API endpoint. And from this API endpoint, you can do a few things. One thing that you can do is you can get the API, the flow deployment ID, right? So you can obtain the deployment ID of that particular flow name and deployment name. So based on the flow name and deployment name, you can get the deployment ID. And deployment ID, so yep, not the flow ID, sorry. The deployment ID is what you need in order for triggering the flow for this particular deployment. So you obtain the deployment ID by using the base URL /deployments/name flow name and deployment name. So flow name, deployment name is that unique combination that returns in the deployment ID. Once you have the deployment ID with you, then you can do several operations on that particular flow run that we are going to do, right? So what are those operations? We can create a flow run, right? We can create a flow run ID. We can, once we have created a flow run ID, we can check whether the flow is still executing or not. And if it is still executing, then we can keep on polling whether it is still executing or not, whether the status of the flow run is scheduled, it is finished, or it is still running, kind of thing. So we can do a few things. We can create, so that's what it is over here. So what we can do is we can create, it's all over. So let's go in this main method and just follow along. So step number 1, we use the flow name and deployment name in order for us to get the deployment ID. So flow name and deployment name returns the deployment ID. And then using the deployment ID, we are creating a new flow. How are we creating a new flow? We are creating a new flow by reaching out to the endpoint deployment ID /create flow run. This is the endpoint for creating a new flow run. So we already have a deployment ID now, and by reaching out to create flow run endpoint, we are going to be creating a new flow run for that particular deployment ID. And this will result in the flow ID for you now, right? So by creating a new flow run, you are able to obtain a flow ID, flow run ID. So which is what you'll see that will pass on some payload to this particular API endpoint, and this payload being the question that we are asking to the large language model. So we're going to pass, well, not to the large language model, but to the flow. So the very first task will be taking up this question, but we will pass on the payload to this flow. And as a result of this, you will get a flow run ID back, which you will use to check the status over and over again, right? So you'll check the status every second in this particular example. And once the flow is finished, you will log everything. So the step number 2 is if the response code is in 200 or 201, you can see, which means that it has actually succeeded in creating the flow run ID, and you are just returning that particular flow run ID back over here, right? So if I go back to the main method, you will see that once you have, where's the main? Right here. So once you have triggered the flow, you have created the flow, you get the flow run ID back, and you have triggered the flow over here. Now you are iterating in a way in an infinite loop kind of thing, and you're waiting with a check interval of 1, and you are checking whether the flow has been completed or not. The way to do that, if you see in the wait for flow completion, is we are iterating over the state, and we are checking if the state is completed, failed, or cancelled. If it is between these 3 statuses, then break. Otherwise, keep on checking the flow state. And how do you check the flow state? There is a helper method over here for it. There is a base URL of the API endpoint, flow runs, and the flow run ID that we have obtained from the previous step, right? So once we created the flow, we got the flow run ID, and then now we are checking for that flow run ID whether it is completed or not. All right. So all that being said, let's go ahead and execute this trigger flow.py method. And what it will do is it will schedule another flow over here, right? So I'm going to keep this deployment open. So deployment and this particular window open, and I will trigger. So let's trigger it right from here. So terminal, new terminal, and let's trigger flow.py from here. And so Python trigger. Oh, I gotta go into that folder. So cd h and then Python trigger flow.py, and this is where, yep, you can see the flow got picked up, and this is the second flow. You can see it is executing, it executed, it got picked up and executed, and it just got done now. Okay, all right. So we were successfully able to trigger a flow, right? From here, we were successfully able to trigger it, and it kept on checking for the status, and it went into scheduled status first, then went into pending status for a few seconds, then went into running status for a little bit, then it was completed, and then it was exited eventually from there, right? It also shows that where locally we are storing the result, because we also set on the LLM flow.py, if you see, there was a local storage enabled for this. So persist result true, which was storing the data locally as well. So you can see the storage key location right here. And if you actually open this, you can see this is the exact same answer that is being stored into the large language model response in the Postgres database too. So I'm going to refresh this page over here, refresh, and you will see this is the answer that is stored in the Postgres database as well. All right, so this was end-to-end flow of how you would use Prefect into a very simple use case, but yet very powerful. So you can invoke the Prefect server's deployed flows, and you can have some workers listening to it. You can do some pre-processing, you can do post-processing, you can store the results in Postgres. It's a very, very powerful functionality for running background jobs, essentially. So tasks that will take longer to process, which your agents do not want to, being held on to right away. So you can delegate that work. You can then get the flow run ID back. So you saw how you can retrieve the flow run ID on the API call to the Prefect server, and the same flow run ID then you can use to query the Postgres database later on to get the results back. So you can store all the results, you can get the relevant information that, hey, this is the handle to get the results back by the flow run ID, and then later on you can use the flow run ID to retrieve the data from Postgres also. All right, thank you everyone for watching this video. Please let me know how you liked it, and I will see you guys in the next video.